So these aren't easy conversions with the double units, the units of rate. So I have 80 pounds per square foot is written as 80 pounds over 1 square foot. And we have to convert both. What are pounds going to be converted into? Ounces is the other unit that's in the numerator. So we're going to get rid of pounds. Where are pounds going to go in my conversion factor here? Bottom. So ounces on top. 1 pound is 16 ounces. So that gets rid of the pounds. We now have ounces on top and square feet on bottom. So we need one more conversion factor. We're getting rid of what unit now? The square feet. And it's going to go where in this factor? It goes on top because it's on bottom. So we need it on top to cancel it out. Going below it's going to be inches squared. So 1 square foot is how many square inches? 144. Very good. So the square feet cancel out. On top, we've got 80 times 16 times 1, which is what, 1,280 ounces. On bottom, we've got 1 times 144 square inches. So 1,280 divided by 144 is 8.89. Bless you. So 8.89 or 8.9 ounces per square inch. Any questions on that one? 30 miles per hour, we'll wait as 30 miles over 1 hour. Let's get rid of the miles first. Where are they going to go? Bottom. 1 mile is 5,280 feet. Good. Miles are gone. We now have feet per hour. What do we need to change next? Get rid of we can go from, we got to start with hours. Get rid of the hours first. We can go to minutes. Let's go straight to seconds. 1 hour is 60 times 60 is 3,600 seconds. I'm just skipping. I can go hours to minutes, then minutes to seconds. I'm putting them all together as one step. So the hours are gone. On top, we've got 30 times 5280, which is 150. Was it 8,400 over 3,600, which gives us what? Was that 44? Perfect. 44 feet per second. Any questions on that one? Next, we've got 4,000 gallons per hour. So 4,000 gallons over 1 hour. That sounds like a pretty hefty pump, doesn't it? Let's go to the gallons first. What are we converting them to? Cubic feet. 1 cubic foot is 7.5 gallons. Gallons are gone. What else do we need to change? We converted the gallons to cubic feet. Hours to minutes. 1 hour is 60 minutes. So the 4,000, the hours are gone there. 4,000 times 1 cubic foot is 4,000 cubic feet. On bottom, we've got 1 times 7.5 times 60 minutes is 450 minutes, which is what, 8.89 cubic feet per minute? Is that right? That's not a bad pump. 9 to 12 cubic feet a minute is a pretty good water pump. Over here, we've got 700 kilograms, bless you, per 1 cubic meter. When we're dealing with both units in metric, we don't have to go through these conversion factors. We can just convert each unit. Kilograms are becoming what? Grams. 700 kilograms. How do we convert that into grams? The decimal to get from kilograms to grams moves how many spots? 3 to the right. So it's 700,000 grams. Cubic meters are becoming cubic centimeters. See, from meters to centimeters is 2 spots to the right. And because it's cubed, we have to go 6. We got to add zeros. That is 1 million cubic centimeters. We divide this out. 700,000 divided by 1 million is 0.7 grams per cubic centimeter. Any questions there? Number 5, 130 liters per 1 centimeter squared. We're converting liters into milliliters. 130 liters is how many milliliters? 130,000. 3 spots to the right is correct. Centimeters squared are becoming millimeters squared. Centimeters to millimeters is 1 spot to the right. Because it's squared, the decimal point goes 2. It doubles that. That's 100. We divide that out. That is 1,300 milliliters per millimeter squared. What do you think? Good stuff? Still better than a sharp stick in the eye? I had a student once ask me, you promise to stop when you hit the back of the skull? The answer is no. So anyway, today we're finishing up this unit, finishing up some of our odd units of measure that we need to work with. We're going to talk about time. Now I've already used time here. We've used that 1 hour is how many minutes? 60 minutes. 1 minute is 60 seconds. Hopefully that's not something we need to review. 1 day, of course, is 24 hours. Now the tricky part with time is if we use weeks or months as our unit of time, the conversions get sloppy. There are 7 days in a week, but how many weeks are there in a month? It varies. The legal definition is 4.15 weeks a month. Or sorry, it's 4.3 weeks a month. It's 2.15 biweekly pay periods in a month. That's legal definition. But yes, it does vary because months go from 28 to 31 days. The time that I want to be concerned with is millisecond. 1 millisecond is how many seconds? It is a thousandth of a second, or 0.001. So 1,000 milliseconds in a second. How about a microsecond? That is a millionth. You are correct. For those of you in automotive, these can be pretty important. Those are your delays and your timing and stuff like that. You have, microsecond delays, so many microseconds before top dead center in your timing and things like that you would deal with. Also, your delays in your electrical components. This component has a 3 microsecond delay. Well, sometimes that delay can change your timing, so you need to adjust your timing for those for different components. Now, at the technician level, most of you won't have to deal with that. It's only if you get to customization, building race engines and stuff like that you'd really have to worry about being that precise with stuff. But it is an engineering feat out there that you have to deal with. your car isn't going to run a whole lot different. But if you're looking for peak performance, if you're trying to pull 1,200 horsepower out of a V8 block, then yes, those little things make a difference. They make a difference of 2-3% in your horsepower, which on a car that's putting out 250 horse, that's 4 or 5 horsepower. Nobody cares. Yeah. If you got a car putting out 1,000 horse, well, then that's 20 horsepower. That makes a bigger difference. Okay, so the big thing that we want to talk about today is converting temperature. When we talk about temperature, we have 2 benchmarks that we really look at. We have water freezing and water boiling. We'll talk about that in a second. Just because I don't want to spell Fahrenheit, we're going to label 1 degrees F. That's our standard scale is Fahrenheit. Celsius I could spell, but to be consistent, we'll just call it degrees C. That's the Celsius scale. In the Fahrenheit scale, what temperature does water freeze? 32 degrees Fahrenheit. What temperature does water boil? 212. There we go. That's actually one in the last few years I've noticed more and more students don't know is the boiling for Fahrenheit. The Fahrenheit scale started out with just the coldest day they could imagine was labeled 0, and then they went from there. So it was really the starting point, 0, was very arbitrary there. Celsius scale, water freezes at what temperature? 0 degrees Celsius. Water boils at 100 degrees Celsius. That difference, of course, is 100 degrees. Because there's 100 degrees between freezing and boiling, the Celsius scale is sometimes referred to as the centigrade scale. Centi meaning 100, grade meaning divisions. There's 100 divisions between freezing and boiling. On the standard scale, there's how many degrees between? If I subtract that out, that's 180 degrees. So what that's saying is 1 degree Celsius is larger than 1 degree Fahrenheit. There's 180 of those Fahrenheit degrees and only 100 of the Celsius degrees between there. Now there is one major issue with our temperature that we did not run into with any other measurement that we worked with. And that is there's no common 0 point. Every type of measurement we did, 0 was 0. 0 feet equals 0 centimeters, equals 0 miles, equals 0 kilometers, equals 0 inches. For mass, 0 grams equals 0 kilograms equals 0 pounds. For capacity, 0 liters equals 0 gallons. 0 was 0. In temperature, it's not. Because of that, temperature converts very differently. We can't just use a conversion factor to convert the temperature. The conversion factors come from these ratios here. What is the ratio of 180 over 100? If I reduce those, what can both of those, now I can't turn it into a mixed number. I'm just going to reduce them. Both of those can be divided by 20, gives me 9:5. Or if I did the ratio the other way, is 100 over 180. Well, they can still both be reduced by 20, gives me 5:9. So the ratio between a degree Fahrenheit and a degree Celsius is either 9:5 or 5:9, depending on which direction you're going. The other thing is the 0 point goes from 32 to 0. There's a difference in the 0 point. Both of those have to be accounted for when we convert. So if we are going from degrees Fahrenheit into degrees Celsius, our Celsius temperature. We have to take our Fahrenheit temperature, and the first thing we have to do is adjust that starting point. So we subtract the 32 degrees to put it down to 0. Divide by 1.8 or times 5/9. That's that ratio. So today it was, what, 28 degrees when I left home, I believe. 28 degrees Fahrenheit. What's that going to be in degrees Celsius? Well, this will be 5/9 times 28 minus 32. What is 28 minus 32? -4, right? Then we take that -4 over 1. 5/9 times -4 over 1 is -20 over 9, which is -2.22 degrees Celsius. So you can tell your friends it was below 0 this morning. Technically it was, yes. The other one I like to do is human body temperature, 98.6 degrees Fahrenheit. So we have to convert that into Celsius. Take the 98.6 minus 32 and then times the 5/9. What is 98.6 minus 32? Dead? Why dead? 98.6? Well, this is converting into Celsius, though. So then 5/9 times 66.6, 37 degrees. So human body temperature is actually 37 degrees Celsius. Pretty drastic fever would be like 39 degrees Celsius. It's a pretty good fever. If you want to go the other direction, if you want to go from degrees Celsius into degrees Fahrenheit, our Fahrenheit temperature is found by taking our degrees Celsius. Instead of times 5/9, it's times 9/5. Then we have to add that 32 degrees on it to account for that change. So what if I tell you that the radio comes on and says it's going to be 25 degrees Celsius today? Is that a good day, a nice day, or a bad day? Let's do 9/5. We'll put 25 in here for C. Plus 32. 9/5 times 25 is 45, right? Is that correct? 45 plus 32 is 77. I would take a 77-degree day. Oh, sure. Now, using the formula, I want you to tell me. Let's say that our minimum temperature this winter is negative, just don't know what happened there, negative 40 degrees Fahrenheit. Convert that into degrees Celsius. In your notes, make that conversion for me. We'll talk. Yes. So let's plug this in. Go from Fahrenheit to Celsius. It'd be negative 40 minus 32 and then times 5/9, right? Negative 40 minus 32 is negative 72. Multiply that out, it is negative 40 degrees. Negative 40 degrees is the one temperature that's the same in both scales. It would have been nice if we'd have set that at 0 or something like that, but we didn't. So we're done with your packet, so we are back in your book now. Pages 154, 1 through 31, the odds. And page 156, 1 through 19, the odds. Remember, tomorrow is Unit 3 test. On that Unit 3 test, you need all these measurement conversions. You need to have all of these. What else was on there? Give me just a second. All your operations with measurements. So that's our test tomorrow. Make sure you know how to do those. Unit 4 is going to be reading meters, micrometers, calipers, and more basic algebra. How many word problems on the test? Actually, I tried to be nice on this one. Don't get used to it. I'm not good at it. And the number of word problems is 0. There are bonus questions. The third thing, by the way, remember that scientific notation and the powers of 10. That's the one that people tend to forget about.